Let's continue with the IB Mathematics Standard Level course, now with class number 13. Class number 13 is about descriptive statistics. From its name is, we have two words, is descriptive and statistics. Descriptive statistics is like we're surveying a big data, big amounts of data, and descriptive, we need to describe this data. So whatever you need to generate a report, let's say to head of business, to head of school, since you know schools, you need to give certain measures to describe a big data. It does not make sense to go over each piece of data for someone that does not have that time, or it's really hard to interpret very, very large amount of data. So you need measures to describe this data. That's why we're saying descriptive statistics. So for these measures to describe data, we have two types of measures. So measures to describe my data, I have two types of measures. The first type is measures of location. Measures of location is where each piece of data is located within my data set. So within my data set, I need to find where this piece of data is located, where the 50%, what's the value of the 50% of the data, or what's the value at the location of 25%. So we need to find the measures of location. To start with the measures of location, we have the mean. The mean, which is the average. The average, simply, we sum out our data and we divide by its number. This is my mean. It finds the average of my data. Another measure of location is the median. The median is the 50% of my data. The median is the 50% of my data, or where my half of my data is located. We can calculate the median after ordering our data in an ascending order. So the mean and the median are called, or are classified to be measures of central tendency. Measures of central tendency. The mean and the median and the mode as well is a measure of central tendency. The mode is the most frequent piece of data. This is my mode. The mode is the most frequent piece of data. The three of these, the mean, the median, and the mode, are considered to be measures of central tendency because they are hitting towards the center of the data. Now you may ask sometimes when I'm going to use the mean as a measure of central tendency or the median. The mean is a measure that's highly affected by outliers. So if I'm having outlier, the mean will be biased. We call it biased because let's say I'm having a class having scores out of 10. All the class has a score 3 and a 4, and 2 of them have full marks, 2 10s. So when you calculate the mean will be higher than 4. It will be biased because of these outliers, which is the 2 students scoring a 10. While the median is not affected by outliers. So simply, when in my data I find outliers, I use the median or the mode as a measure of central tendency. I don't use the mean. Otherwise, it's fine to use the mean. These three measures are measures of central tendency. Other measures, I have quartiles. Quartiles is from the word quarter, is like the first quarter, the second quarter, and the third quarter. The first quarter, which is Q1, it's at the 25% of my data, or the 1/4. I have the Q2, which is the 50%, which is the same as the median. And I'm having Q3, which is the 75%, which is 3/4 of my data. These are my quartiles. Another measure of location is the percentiles, is each percentage within my data. Percentiles. Percentiles, I'm having like the P10, which is the 10% of my data. I have like the P50, which is again is my median. These are my percentiles. So all of these are considered measures of location. Let's go to my second type of measures, which are measures of dispersion. These measures of dispersion give me an indicator how the spread of my data is. How large is my data is like by calculating the maximum minus the minimum. How much my data is deviated away from the mean. So these are measures of dispersion. We can start with by the range of my data. The range is equal to the maximum value minus the minimum value, as simple as this. I have another measure of dispersion, which is IQR. IQR is called the interquartile range. The interquartile range is equal to the third quartile minus the first quartile. And another measure of dispersion, which is so important, is the variance. The variance calculates to me how the data, all values of data in my data set, is deviated away from the mean. So my variance is equal to sigma square, as a measure of the deviation of my data around the mean. This is my variance. And I have another important indicator as well, which is the standard deviation. And the standard deviation is simply the square root of the variance, is equal to sigma, which is the square root of the variance. Now we can go to example with real values, and we can go and describe our data. Let's say I'm having the score of students out of 10 in a mathematics exam. Let's say I'm having a 2, I'm having a 3, I'm having a 3. I want to make them in an ascending order. I'm having a 1, 4. Then I'm having a 5, a 7, I'm having an 8, I'm having a 9, and I'm having a 9, and I'm having a 10 here. Let's label our data. This is 1, this is the second, this is third, fourth, fifth, sixth, seventh, 8, 9, 10, and 12. The use of the graphical display calculator is really essential in these cases, because sometimes, or most of the times, in your exam, in paper 2 exactly, you don't need to do the calculations. Everything you have it on your GDC. So all you have to do is to fill the list, and 2 clicks and you get all the values you want. Let's check our GDC. Let's start it. Let's say I want the mean, I want the median, I want the mode, I want the standard deviation of this data, I want the quartiles, I want everything describing this set of data. We can go now to stat, and we have the edit because we want to fill the list. We press enter. We start by filling our data. We have a 2, then 3, 4 times. Then I'm having a 4 and a 5, 7, 8, 9, 9, and finally a 10. If you can see here down, I'm having L1 having 12 data pieces in it. So, to find all my measures describing this data set, I go to stat, and then I go to calc. Is a one var because it's one variable here I'm having, is a one var stats. I press and enter. I want one var stats for which? For list 1. So I go second, L1. And I press enter again. So I'm having an X bar, which is the mean, which is 5.5. So now I know my mean. Which is equal to X bar is equal to 5.5. What else do I know? I go down, I find sigma x. Sigma x, which is the standard deviation, is 2.78. So sigma, which is the standard deviation, is 2.78. If I want the variance, is simply sigma squared, is you square this value, is 2.78, and you square it. What else do we have? Do we have the range? Calculator, do we have the range? No, it does not count, but it gives me the maximum value of x, which is a 10, and the minimum value of x, which is a 2. So I can find that the range is equal to the maximum value minus the minimum value, which is a 2. So is equal to 8. What else do I have? I have the quartiles and I have the median given by my calculator. So Q1 is a 3. My median is 4.5. So Q1 is equal to 3. Q2, which is my median, is equal to 4.5. And Q3 from my GDC is equal to 8.5. So Q3 is equal to 8.5. Now, what else can I find? I can find the IQR, right? Which is simply subtraction of Q3 minus Q1. So the interquartile range is equal to 8.5 minus 3. So IQR, which is the interquartile range, is equal 8.5 minus 3, which is 5.5. This is my interquartile range. What else can I find? Okay, it's enough from my GDC. Now, can I know my mode? Yes, of course I know my mode. My mode is the most recurring value. My mode is the most recurring value, and I can find the 3 to be the most recurring value. So my mode here is equal to 3. I hope it's clear. And I want to use this data set to introduce to you the box and whisker plot. To introduce the box and whisker plot. The box and whisker plot let me draw. This is a line. This is my box and whisker plot. In my box and whisker plot, I didn't finish. So this is an outlier and this is an outlier. In my box and whisker plot, this value here goes off to the Q1. And this in the middle to the median, which is Q2, and this is Q3. This value in here is equal to Q1 minus 1.5 IQR, which is the interquartile range. This value in here is Q3 plus 1.5 IQR. So any value greater than this value or less than Q1 minus 1.5 IQR is considered to be an outlier. So this is an outlier. And here I'm having another outlier. These are my outliers. So let's fill my box and whisker plot for our data set. For our data set, the Q1 I'm having is a 3. This is a 3. The Q2 is the median, which is I'm having it as a 4.5. And the Q3 is 8.5. For my data set, I don't have outliers because the 10 won't be greater than 1.5 IQR. Let's calculate the value for Q1 minus 1.5 IQR. And so the Q1, 3 minus 1.5 times the 5.5 will be in the negative. So I don't have an outlier. So this value is a negative for my data. I don't have for my data an outlier here. And the other value would be like, let's calculate it, is a Q3, which is 8.5 plus 1.5 times 5.5, which is another big value, which is around, this is, let's see our GDC. Okay, I want 8.5 plus 1.5 times 5.5. This value is 16.75. So this is 16.75. So for my data, I don't have an outlier. For my data, I don't have an outlier here. This is 16.75. Another way is that we can group this data. We call it in a grouped frequency table. Is like each piece of data, we can put it in a column, and the other column is the frequency of recurring of this data. Like we can give or visualize this data in another form, which is a grouped frequency table. My grouped frequency table would be let's draw our table. This is my table. This is my X value, and here my frequency. So I'm having the 2 once. The number 3 I'm having is 4 times. The number 4 I have it 1 time. The score 5 I have it 1 time. 7 I have it 1 time. The 8 I have it 1 time. The 9 2 times, and the 10 is a 1 time. So the sum of these frequencies must add up to 12, which is, this is a 6 and this is a 6. The sum of the frequency is a 12. I can find the cumulative frequency, which are the sum of individual frequencies. So here I'm having 1, then plus 4 is a 5, 6, plus 1 is 7, 8, 9, this is 11 and 12. And you must make sure when making the cumulative frequency that this value is the same as the sum of all frequencies. This value is the same as the sum of all frequency. This is how we can construct a cumulative frequency table. We can get many interpretations from cumulative frequency table. Already the grouped frequency table is really important and easier to visualize. Like here, directly instead of counting, this is the 4, which is the biggest number. I can find that the 3 is the mode. I can know that my mode is 3 simply by looking at these numbers. And to put my data in tables, it makes it easier to visualize and faster to get whatever you want out of your data. This is how, like, to describe our data. Many methods. You can use stem and leaf diagrams. You can use like histograms, bar charts. Sometimes there's a form of violin charts. So whatever makes your data visualization nice and easy to interpret would be good. So now let's go and solve a question from the question bank. I'm having my example here. This is a data already given in a frequency table, the X values and their frequencies. Part A, I write down the mode. Simply from my data, the mode is my most frequent value. The most frequent is the 28, which is the 10. So my mode is X is equal to 10. This is my mode. Find the value of the range. The range is the biggest value minus the smallest. The biggest value, I'm having X here to be an 11, and the smallest value X to be a 2. So the range is equal to 11 minus 2, which is equal to 9. Find the mean and find the variance. So here, to find the mean and to find the variance, I think we can go to our calculator, and now I want to teach you how to deal with the table having the values and having a frequency list. So I go to my GDC and I go to stat, edit. I need to clear this value. I go to list 1, I clear, then enter. So my list 1 is cleared. I have to fill the X values in list 1 and the frequency in list 2. So this is 2, 7, 10, 11. This is for list 1. Let's fill the frequency. This is 8, 15, 21, 28, and 3. I filled my lists. Now I have to go to stat. I go to calc, and it's also a one variable stats because I only have an X. Even though I'm having frequency, I'm having this X. So I'm having the X and the frequency. But I have to tell my GDC that I'm having another list mapping to the frequency. Let's see how we can do it. We press and enter. We want a one variable stat for list 1, second L1. And the frequency list is in list 2. So I press the comma here. And I go second L2. Now my calculator understands that I'm having a table for the variable which is in list 1 and the frequency of the occurrence of that variable in list 2. For your graphical display calculator, you'll get an easier window which is ask for the variable and ask if there is a frequency list. So now all I have to do is press my enter. So I'm getting the X bar to be 7.15, which is the mean. 7.15. So my mean is the X bar, which is equal to 7.15. 0.15. This is my mean. Do I have the standard deviation? Yes, I'm having the standard deviation to be 2.91, which is sigma. 2.91. So my variance, which is sigma squared, is equal to 2.91 squared, which is the standard deviation squared, which is equal to, let's find it using our GDC. Let's just clear these values. I'm having a 2.91 to the power of 2, which is 8.47. My variance is 8.47. So by this, we had measures to describe my data in this table. I hope what we've covered is really good for you. In stats, it's really important to know how to use your graphical display calculator really well. And as always, at the end of each class is you have to see many data sets, you have to be able to describe it, and you have to keep practicing.